DARPA and Northrop Grumman have unveiled their latest unmanned aerial vehicle. Its features are absolutely mind-blowing. DARPA's newest X-plane, the XRQ-73, also known as the Shephard program, is a hybrid electric uncrewed aircraft designed to meet an undisclosed urgent operational need. Its advanced hybrid propulsion engine positions it as a standout in experimental aircraft, pushing the boundaries of current technology. So, let's take a look at what this aircraft does and what makes it stand out. The XRQ-72A, or Great Horned Owl aircraft, was commissioned over a decade ago, in 2011, but was never revealed to the public. The drone was ultra-quiet for surveillance and intelligence gathering and featured a hybrid electric propulsion system. Scaled Composites, a division of Northrop Grumman and a frequent collaborator with DARPA, created it. However, IARPA, the Intelligence Advanced Research Projects Activity, and the AFRL, Air Force Research Lab, commissioned the Great Horned Owl as a stealth UAV or uncrewed aerial vehicle. The most crucial function of a stealth UAV is being undetectable while on intelligence, surveillance, and reconnaissance or ISR missions. If enemy sensors discover it, it has failed its mission, despite how much information it might have gathered. The hybrid electric system that the Great Horned Owl worked on and that Shephard will improve on was developed as a response to the shortcomings of battery-powered UAVs. They often needed more endurance and were sometimes heavy due to the batteries. This prompted developers to search for more efficient propulsion techniques that didn't compromise on stealth. This technique is the hybrid propulsion system, which powers 4 fan propellers on top of the drone's wing fuselage. The hybrid system comprised 2 fuel-powered generators that produced electricity for the fans. This replaced the typical turbo engines used to power aircrafts, which could be found in the fuselage of stealth drones. This unique propulsion system not only made the Great Horned Owl stealthier than other drones due to the more streamlined planform, but also ensured that the drone didn't emit any thermal energy. This upgrade meant that the Great Horned Owl was virtually undetectable to thermal sensors, making it the perfect drone to bypass radar and avoid detection or destruction by enemy missiles. The hybrid engine is also much quieter than a typical design, with a barely detectable acoustic signature, once again defending it from the sound recognition sensors. The Great Horned Owl's planform is standard and similar to other winged UAVs and previous Northrop Grumman designs. Its wingspan is about 30 feet with wings of about 11 feet from nose to tip. The Great Horned Owl stands about 4 feet tall with its attachments, such as the vertical wingtip stabilizers. The development of this drone was very secretive, and its use was not made known to the public. While this isn't necessarily out of place for intelligence agencies, drone enthusiasts were thirsty for any information that could be gathered on it. The war zone had to pry the information out of the agency's hands in order to release information on its schematics and design years after its commission. The Great Horned Owl could stay in the air longer than previous ISR platforms due to its hybrid engine, which didn't rely on combustion alone, but converted it to electricity. This means it could be taken out for longer missions and had a higher endurance. The documents obtained by the war zone claimed that the XRQ-72A could fly at a speed of 50 keys, knots equivalent to airspeed, but that the program's primary focus was exploring and development of more efficient and stealthier UAVs. It was also developed as a means to explore hybrid propulsion techniques and how to refine them for fuel efficiency, speed, reduced acoustic signature, and more. Like its predecessor, news and information on the Shephard have been kept secretive. However, unlike the Great Horned Owl, DARPA announced the Shephard and shared details on the drone. So, what are some of the features of DARPA's latest stealth and ISR drone? The Shephard program, tagged the XRQ-73, was announced with its official X-plane designation in June 2024. As we mentioned before, the Shephard program is an X-Prime program from DARPA that combines the hybrid technology of previous X-planes with some of the component and hardware designs to create a leveled up aircraft on a scale we've never seen before. The Shephard program manager Steve Comodina explained the X Prime program, saying that the idea behind the DARPA X Prime program is to take the emerging technologies and burn down system-level integration risks to quickly mature a new missionized long-endurance aircraft design that can be fielded quickly. In other words, the X Prime program is all about picking the best ideas, concepts, and technologies and speedrunning the process of making them viable for service. In a statement, DARPA confirmed that the XRQ-73 will be a Group 3 UAS with a weight of 1,250 pounds and is expected to launch towards the end of 2024. The XRQ-73 is expected to be ultra-quiet and highly efficient thanks to the hybrid engine in the autonomous flying aircraft. Scaled Composites is also attached to the project as a major supplier, while Northrop Grumman's aeronautics systems sector is the aircraft's main contractor. Other major suppliers include Cornerstone Research Group, Brayton Energy, PC Crows and Associates, and Eagle Picture Technologies. Looking deeper into the Shephard and the X Prime programs is interesting, as we can compare the Great Horned Owl and the Shephard. For example, the Great Horned Owl was powered by gasoline or diesel, while the fuel source for the Shephard's hybrid engine hasn't been revealed. The Shephard program has been in development for at least 4 years, and DARPA is looking to make it rapidly fieldable. According to their website, the Shephard aircraft will be larger than the Great Horned Owl. It will have operationally representative fuel fraction and mission systems while staying below the Group 3 UAS weight limit. The Group 3 limit for unmanned aerial systems refers to systems with a maximum takeoff weight between 55 and 1,320 pounds, a nominal operating altitude between 2,500 feet above ground level and 180 feet at flight level, and a speed between 100 and 250 knots. The DARPA website also referred to Shephard as an existing option to the Air Force Research Laboratory Great Horned Owl contract. This could refer to the fact that the Shephard will be directly improving on the features of the Great Horned Owl, particularly the hybrid propulsion engine, while retaining some of its components and architecture. They did not specify if the Shephard will be connected with the Air Force Collaborative Combat Aircraft Project, which was launched by the Air Force to modernize its fleet. The Unmanned Collaborative Combat Aircraft drones are supposed to serve as wingmen to the next generation Air Dominance Program's fighters, which will be manned. The Air Force funded both the CCA and the NGAD with over $30 billion for the next 5 years of development, so it wouldn't be a surprise if DARPA jumped on the opportunity to develop some more advanced drones. Now, let's look at some theories on the features of the Shephard. Since DARPA didn't provide too much information about it, due to the hybrid propulsion engine, we already know that it will be nearly undetectable on radar and infrared sensors, and potentially invisible to heat-seeking missiles. We also know that it will be silent and stealthy for better reconnaissance. We also know that since the Great Horned Owl was developed to test for things like stealth, endurance, and longevity, the Shephard will likely outclass the GHO in all of these categories. Specifications such as the wingspan and height were not disclosed, but the given weight and hint at these figures. DARPA shared that the Shephard will weigh 1,250 pounds, near the upper limit for Group 3 UAVs. The Shephard was also said to share components with the Great Horned Owl, which weighed about 400 pounds. While the Shephard weighs about 3 times more than the GHO, this weight difference might translate into height and not wingspan. While the X-planes are typically used for demonstrations as their name implies, experimental planes, the Shephard program was designed to bridge across technology's valley of death, and more prototypes and demonstrations into battlefield-ready machines. Some ISR vehicles can already fly missions for up to 24 hours, such as the MQ-9 Reaper. While the Reaper isn't the most advanced or flashy drone, it is one of the most widely produced and features defense capabilities and long fight endurance. The Valkyrie, or XQ-58A, is another very impressive drone. This fighter jet support drone was launched in 2023 and can be controlled by ground operators or an artificial intelligence system. Its standout feature is that it is affordable to produce and highly replaceable, and can therefore sacrifice itself to protect any human-crewed aircraft it accompanies. Standout UAVs are also developed by China, Russia, Turkey, and many other countries. One of the most impressive drones in development is the Boeing MQ-28 Ghostbat, developed in Australia. It features integrated sensor packages for intelligence, surveillance, target acquisition, and reconnaissance, also known as A-STAR for missions, and is fully armed with a combat radius of 900 miles. Many countries have developed drone technology for surveillance, defense, or information gathering. In the United States, unmanned aerial vehicles and systems are prevalent in the military and defense sectors. As impressive as the Shephard program is, many other noteworthy drones, UAVs, and aircrafts might interest you. Which of these drones sounds the coolest to you? Let's hear your thoughts in the comment section. Don't forget to like, share, and subscribe to our channel for more captivating and fascinating content. Thank you for watching, and we'll see you next time.